Okay, this is a little bit of an introduction to the derivative of a function. I just wanted to teach you about this before you dove into the worksheet. So when you look at the worksheets, it will make some sense to you and you won't be wondering what's going on. So basically, I have some functions here that I made up. Well, I didn't make these up. This is the absolute value function. This is x squared, a parabola. And this is, I made this up. It's some function that looks like that. Okay, so if we have to graph the derivative of this function, what you always have to keep in mind is what the graph of the derivative is a picture of the tangent line at every point on this, okay? The slope of the tangent line of every point. So if you look at this absolute value function, you would ask yourself, what is the slope of the function at this point? What is the slope of the function at this point? What is the slope of the function at this point, at this point? So we see this is always at the same slope. It's always at the same angle. And so given that this is the absolute value function, this slope is -1 until you get on this side and then you see it's doing something different. But all the way from -infinity till x is 0, the slope right here is the value -1. And at 0, it does something very abrupt. It changes, and the slope goes instantly from being -1 to +1, because it's a positive slope. If we looked at the rise over the run over here, that would be 1. What is it at this point? The slope is 1. The slope is 1. The slope is 1. The slope is 1 the whole time. So how could you graph the derivative of this function? Well, y equals to -1 all the time is a horizontal line. So we'll be down here at -1. Okay, and where is this happening? This is happening for values to the left of 0. Okay, and then, but once it hits 0, it jumps up here to 1. So if this is 1, then y equals to 1 is what it looks like on that part. So this, you could make these open circles right here if you wanted to. I don't know really who 0 belongs to, probably neither one, but that's kind of a picture of the derivative of that. The slope of this function is -1 down here, and then it's 1 over here. Now, this is a curve, so it will not have this kind of just line just like that. So it's changing all the time. This was not changing, that's why it was constant. This slope is always changing, the slope of the tangent line. So let's look at what it's doing. Well, you would ask yourself, well, what does the slope look like here? Well, right here, the slope of the tangent line would be negative, and it would be like at that angle. And then it would still be negative, but it's not quite, the slope is not quite as steep. It's a little bit more shallow. And as it comes in here, it gets more shallow and more shallow. When it gets to 0, it's at 0. It's got a flat slope. The slope of that line is 0. So we know at 0, the slope is 0. That's one point we know. And then we know when we get to this side of 0, it's positive, and then it's more positive, and then it's more positive, and it's more positive. So what we have here is something that's a big negative number, and then not as negative, and then not as negative, and then not as negative. What is negative? Something below the x-axis. So we have something down here, and then when it gets to 0, it becomes positive, and then it gets more and more positive. This is what the derivative of this would look like. A picture of his slopes would look like this. All right, let's come over here and see what this guy's doing. What is the slope of this line right here? It's flat, it's flat, it's flat. It's 0, it's 0, it's 0, it's 0, it's 0, all the way till we get to this x value of -2. So that means if we're over here at -2, the slope is, and let me do it in a different color so we can see. I'll do the graph in black. The slope of this is 0, all the way to the left, -2. It's right there on the 0 line. Well, what's happening here at 1? It's flat. It's still 0. So this is a 0 slope, and this is a 0 slope. So over here at 1, once it gets to the right of 1, it's also at 0. That's 1. The question is what's happening in between. All right, what's happening in between? Well, over here at -2 and over here at 1, I gave us 2 points so we can just straight calculate the slope, changing y over changing x. So the slope here is going to be 3 minus -2, which is 3 plus 2, which is 5, over -2 minus 1 over -3. It's -5/3. And does it change? No, it's -5/3 the whole time. So this is just going to be y equals -5/3. So we're going to go down here to -1, -2, -5/3 is going to be somewhere here, in between here. This is what this slope looks like. So this is a picture of the derivative of that function. So that's kind of how this works. And so when you get to the worksheets, it should make a little more sense.